morning, everybody. I am Vempati Srinivasulu, Assistant Professor of Chemistry, Nagarjuna Government Degree College, Nalgonda. We are studying amines, cyanides, isocyanates. Today, we'll start the lesson about cyanides. Today, we'll start the lesson about cyanides. Okay, it is written here. It is cyanides. Okay. Cyanides. We'll discuss about cyanides. Before going to the class, what we have discussed in the previous classes. Once again, we recap fast. What are amines? What is the classification of amines? In what way we name the compounds, IUPAC nomenclature and common naming system. We have discussed this naming system with various type of examples. Then preparation of amines from 5 methods: from ammonolysis of alkyl halides, reduction of amides, Hoffman method, and Gabriel Thalymide method, so etc. So and Smith reaction. From these 5 methods, we discussed how to prepare amines. Then we discussed about phase transfer catalysis, how our tetraammonium salts work as phase transfer catalysts in different organic compounds, especially in nucleophilic substitution reactions. We discussed in detail. Then we discussed physical and chemical properties of amines. Basically, alkylation, acylation, carbyl amine reaction, Hinsberg method of separation of mixture of amines, and a reaction of amines with nitrous acid, and especially focused on basicity of amines. So then after that we discuss diazonium salts. What are diazonium salts and what are its properties, especially Sandmeyer reaction and Guttman reaction, Schumann reaction, and coupling reactions. In the previous class, last class, we discussed these reactions. So from Sandmeyer reaction, you will get chlorobenzene or bromobenzene. From Guttman reaction, along with these, we'll prepare iodobenzene. Schumann reaction is used to prepare especially for fluorobenzene or nitrobenzene. And coupling reactions are the reactions in which two organic benzene moieties or aromatic ring moieties may combine through a diazo group, what we call as diazo compounds. Then, so that is yesterday's class. Today we will discuss about cyanides. What are cyanides? What is the structure of cyanide group, functional group, and what is the nomenclature methods? What are the naming systems methods we use to name them? Then preparation of cyanides from with different source of compounds from different starting materials. Then some chemical properties of cyanides. All these things we'll learn. Alkyl cyanides are the compounds which contain cyanide as a functional group, CN. This is a CN. You see, this is a CN. C triple bond N. The compounds with CN function group are called cyanides. Generally, these are the formula. RCN is the common formula of cyanides. So these are the derivatives of hydrogen cyanide. So in the place of H, it is replaced by alkyl or aryl group. So we can get different cyanide compounds. For example, you see CH3CN, C6H5CN. So these cyanides are isomeric with isocyanates. That means cyanides and isocyanates are functional group isomers. Okay. Nomenclature. In the naming system of cyanides, we follow two methods. In the common method, we name these compounds as alkyl cyanides. In the IUPAC method, we call as nitriles. Cyanides. As a functional group, we name this as cyano. Cyanoalkanes are nitriles. In the IUPAC nomenclature, we call them as cyanoalkanes or nitriles, alkyl nitriles. Generally, on hydrolysis, these cyanides give acids. That's why we name these compounds as acid. We name the acid, remove the we add O and followed by nitriles. We will see the example. For example, this is CH3CN. So this is methyl cyanide. We call this as methyl cyanide or cyanomethane. If CH4, it is CH4 methane. But one of the hydrogen is replaced by cyanide group. That's why it is cyanomethane. In IUPAC nomenclature, this is also called as acetonitrile. Why? Because on acid hydrolysis, this will give acetic acid. That's why we give the names as derivatives of acid. That's why this is acetonitrile. CH3CN, we call this as acetonitrile. In the same way, we give this name, this compound as propionitrile or ethyl cyanide. Ethyl cyanide. Then you see this compound. C6H5CN, phenyl cyanide or cyanobenzene or benzonitrile. Why? Because in hydrolysis, generally cyanides gives carboxylic acids. So this phenyl cyanide on hydrolysis with the water, it will give benzoic acid. That's why it is benzonitrile. Benzonitrile. Phenyl cyanide, cyanobenzene or benzonitrile. So coming to this one, it is also benzonitrile, but in the third position, it has hydroxy group. So 3-hydroxybenzonitrile or 3-hydroxyphenyl cyanide or 3-hydroxycyanobenzene. So these are the different names in different naming systems. Then this one, what the name of this compound is? See, benzyl cyanide. Actually, this is benzyl cyanide, but in the phenyl we have four phenyl, 4-nitrophenyl methyl cyanide. This is the name of the IUPAC name in the IUPAC system. Or acetonitrile is there, but in the second position we have nitrophenyl, 4-nitrophenyl. So 4-nitrophenyl acetonitrile. So this is the name of this compound. Coming to this compound, where is cyanide group is there and pharmalyl group is there. We have to give the priority to cyano group. So we have to get the priority for cyano. That's why this is a cyano compound. This is the longest chain. We have to give the number for cyanide also, first carbon in the IUPAC nomenclature. Or in common method, it's alkyl. So 1, 2, 3, 4, butyl, N-butyl, 2 pharmalyl, N-butyl cyanide. In the IUPAC, this is a pentanoic acid. It will use pentanonitrile, pentanonitrile. But in the third position, we have pharmalyl, 2, 3 pharmalyl, pentonitrile. So these are the different names of different cyanides. Whenever we think about cyanides, we'll recall potassium cyanide, sodium cyanide. These cyanides are very toxic in nature. Whenever you expose to the cyanide, it's very dangerous to our health. Within a short time, a man will die. There is a lot of metabolic reaction takes place, which causes more poisons to the body. That's why the patient may die within minutes or within seconds sometimes. Okay, this is the naming system of cyanides. So what are cyanides? The common formula is RCN. These are the derivatives of HCN. So common form, methyl cyanide, phenyl cyanide, okay, acetonitrile. These are the different names. Next slide. Okay. Preparation methods. How do we prepare these cyanides? We'll see. First method is, you see, from alkyl halides, RX or alkyl halides. When these alkyl halides react with KCN, potassium cyanide, or sodium cyanide, those will give these compounds, alkyl cyanides. Okay, this is RCN. So once again, alkyl halides, when they react with the potassium cyanide or sodium cyanide in alcoholic medium, alcoholic KCN, when KCN is dissolved in ethyl alcohol, we call it as alcoholic cyanides. So these alkyl halides, when they react with the potassium cyanide or sodium cyanide, they will give corresponding cyanides. So for example, you see, this is a methyl chloride, chloromethane. This is chloromethane or methyl chloride. When this methyl chloride reacts with potassium cyanide, it will give methyl cyanide or acetonitrile. What is happening in this reaction is Cl is being replaced. Cl is getting replaced by cyanide. This cyanide, Cl is replaced by cyanide. Cn is a strong nucleophile. Cl is chloride is weak nucleophile. This cyanide replaces this chloride. That's why alkyl halides undergo nucleophilic substitution reactions in presence of alcoholic potassium cyanide or alcoholic sodium cyanide. So that's why our methyl chloride On reaction with alcoholic KCN, it is giving methyl cyanide or acetonitrile. Along with this, we will get KCl. The second reaction, you see ethyl bromide, bromoethane. This bromoethane on reaction with potassium cyanide or sodium cyanide, by liberating our sodium or potassium salts, we are getting corresponding cyanide, that is ethyl cyanide, cyanoethane or propionitrile. Coming to the next example, it is benzyl iodide. When benzyl iodide reacts with potassium cyanide, it is giving benzyl cyanide. Okay, phenyl acetonitrile. This is the one method of preparation. What is this? Alkyl halides, when they react with potassium cyanide or sodium cyanide, they will get corresponding cyanides. This is the one method of preparation. Come on, next slide. From preparation from amides, you see these are amides. So when amides, they react with the phosphorus pentoxide by heating. On heating, it is giving alkyl cyanides. So we can get alkyl cyanides from amides. When amides react or pass through phosphorus pentoxide, these amides undergo dehydration, OH2, so removing as H2O. So we are getting cyanides. It is a dehydration reaction. So amides on reaction with phosphorus pentoxide, they undergo dehydration reaction by giving cyanides. For example, this is benzamide. Benzamide, on treating with the phosphorus pentoxide, we are getting phenyl cyanide or cyanobenzene or benzonitrile. So one more example. You see this one, propionamide. This is propionamide. On reaction with phosphorus pentoxide, on dehydration reaction, it is giving propionitrile. So all in these reactions, we are losing one carbon. No. Same carbons. We are getting cyanides from amides with same number of carbons. Okay. Okay. Then preparation from aldoxime. Oximes are the compounds when hydroxyamine react with the carbonyl compounds, aldehydes or ketones, they will give corresponding oximes. When this hydroxylamine reacts with aldehyde, we get aldoxime. You see in this example, it is aldoxime. Why? Acetaldehyde on reaction with this acetaldehyde on reaction with the hydroxylamine, it undergoes addition elimination reaction. First undergo addition reaction followed by elimination of water. That's why it is called condensation reaction. So by eliminating water, we are getting corresponding oxime. If you take acetaldehyde, acetaldoxime. If you take benzaldehyde, you get benzaldoxime. In general, aldoximes. So when aldehyde react with the hydroxylamine, you see this is a benzaldoxime. Why? Because it will get from benzaldehyde and hydroxylamine. It is stable. This benzaldoxime, when react with phosphorus pentoxide on dehydration reaction, it is also a dehydration reaction as in the previous case. amides also undergo dehydration reaction with phosphorus pentoxide. Like that, our aldoxymes also undergo dehydration reaction by giving cyanides. You see, H and OH goes as water. We get one more pi bond between carbon and nitrogen. That's why it is phenyl cyanide or benzonitrile. In the similar way, this is also an aldoxane. You see, this is a propanaldehyde oxime. Propanaldoxime. This propanaldoxime, when they react with the phosphorus pentoxide, you see, undergo dehydration reaction by giving, what is this? Propionitrile. This is propionitrile. Propionitrile. Okay. So this is one of the preparation methods of cyanides. In this method, amides or aldoxymes on treatment with phosphorus pentoxide, by undergoing dehydration, we are getting cyanides. This is one method. Next slide. Properties. We have four properties in our syllabus: hydrolysis of cyanides, reduction of cyanides, reaction with the Grignard reagent, and finally oxidation with mercuric oxide. So we have these four types of reactions. First, coming to hydrolysis. You see, cyanides on hydrolysis, either in the place of acidic or basic media, we are getting what? Acids and ammonia. You see, this is the acid and ammonium salt. We'll get, in acidic condition, we'll get ammonium salt. In basic condition, we'll get ammonia. So what is happening here? Simply, you see, first, alkyl cyanide is undergoing addition to water. So here is OH added, H is added to here. This double bond becomes double bond. So this will get this compound. On addition of water to cyanides, we will get this type of enolic compounds. We know enols undergo tautomization using this type of amides. That's all. These amides as the first step. These amides, when they react with 1 mole water, they'll give acids. What is happening here? You see carefully, in this CON bond is breaking, OH, H is added. H is added to amine, OH is added to RCO. That's why you'll get acid and amine. You see, this is acid ammonia. This is acid carboxylic acid. You see carefully, it is carboxylic acid and ammonia. This is carboxylic ammonia. Okay. For example, methyl cyanide on react with the water in presence of alkaline H2O2. This is giving, this is O is not there, only one O. Enol, this is enol. This enol on undergoing tautomerization is giving amides. That means we'll get amides from cyanides. These amides will get on hydrolysis giving acetic acid ammonia. Anyhow, cyanides, when they react with when they add to water, when they undergo hydrolysis, that means addition of water, they will give carboxylic acids by eliminating ammonia gas. This is ammonia gas. This is ammonia gas. So not only this methyl cyanide or any cyanide undergo hydrolysis reaction by giving corresponding acids. So what is happening in this reaction is our CN bond is or two pi bonds are breaking, OH, H, OH, H. So OH with so these three bonds undergoing fission. So by evolving ammonia, we are getting acid. So first we will get gem triol. This triol on dehydration, this triol on dehydration, it's giving corresponding acid. That's it. So this is one method. Hydrolysis of cyanides. For example, this one is propionitrile. This propionitrile on acidic water hydrolysis, it is giving propanoic acid and ammonia. Propanoic acid and ammonia. So this way we will prepare cyanides from we will prepare acids from cyanides on hydrolysis reaction. This is one of the reaction. First reaction is hydrolysis. Cyanides on hydrolysis with the water. Let reaction with water, either in the presence of acidic condition or basic condition, will get acids or acid salts. These are the examples. Next reaction, next slide. Oh, right. Addition to Grignard reagent is a very important reaction. So cyanides, when they add to Grignard reagent RMGX, the compounds with the formula RMGX are called Grignard reagents. These Grignard reagents are, when they react with the cyanides, they undergo nucleophilic addition reaction. Why? Because R is a carbonyl. In the cyanide, carbon is electron deficient due to pi bond attached to nitrogen. Because of nitrogen high electronegativity, this pi bond is attracted towards nitrogen. That's why our R group adds to carbon. Then a new CC bond is formation taking place. After formation of this type of compounds, on hydrolysis it will give first diol. On dehydration reaction it is giving ketone. So it's clear. This ketone is easily undergo further one more step by adding to RMGX, alkyl magnesium halide, what we call is Grignard reagent. So first it gives this addition product. Followed by hydrolysis, you get tertiary alcohol. This is very important. Alkyl cyanides. So hydrogen cyanide gives second whatever alkyl cyanide, it will give corresponding alcohols. But this Grignard reagent, when they react with our cyanides, two steps takes. In these two consecutive steps, in the first step we will get a carbonyl compound, maybe aldehyde or ketone. There is a ketone. So this ketone on addition reaction with the RMGX, it gives corresponding addition complex. This addition complex on hydrolysis is giving alcohol and MgOHX. So in this reaction, if you use Grignard reagent in lesser quantity, the reaction can stop up to here. Okay. If RM Grignard is very less, when we compare to alkyl cyanide, reaction takes place in one step only. There we stop the reaction. That means we get ketone, carbonyl compounds. On prolonged exposure to Grignard in more quantity, it can undergo one more additional reaction by giving this adduct. This adduct on hydrolysis, it will give what? Alcohols. So it's very important. Cyanides on reaction with the Grignard reagent first undergo nucleophilic addition reaction. So RMGX, R is a nucleophile. This nucleophile attacks on carbon with plus charge. So after this addition, it will give this type of imine compound, a salt of Grignard agent. This on hydrolysis, this bond breaks. This bond breaks. You get that this type of compound. On dehydration, that means once again dehydration. So OH, here should be OH. So on the addition with water, you get a ketone, carbonyl compound. This is a carbonyl compound. We know carbonyl compounds on react with the Grignard reagent. First it will give adduct, followed by hydrolysis. It is giving tertiary alcohols. You see, this is a tertiary alcohol. You get this type of compounds. On hydrolysis, it is giving alcohol. You see, finally it is alcohol. Okay, so this is the reaction. So Grignard alkyl cyanides on reaction with the Grignard reagent, it will undergo a nucleophilic addition reaction by giving an adduct. This adduct on hydrolysis is giving ketones. These ketones once again they react with the carbon Grignard reagent by giving addition product. On hydrolysis you get tertiary alcohol. This is tertiary alcohol. So you have to stop the reaction from here only. We have to use less amount of Grignard reagent, more amount of cyanides. This is a specialty of reaction with the Grignard reagent. So for example, you see methyl cyanide on reaction with methyl magnesium chloride, we get acetone. This in turn on hydrolysis on reaction with the Grignard reagent, it will get tertiary alcohol. This is tertiary alcohol. What is this? Tertiary butyl alcohol. Coming to next. You see one more example. It's a benzonitrile. You see this is benzonitrile. Benzonitrile on reaction with ethyl magnesium bromide, what we get is ethyl phenyl ketone. Okay, phenyl ethyl ketone. This ketone on reaction with this what methyl magnesium bromide will get what phenyl. Okay, diol. First will get diol on dehydration is giving knots. Okay, this is reaction with the RMGX. Next slide. Reduction of cyanides. So when cyanides on reaction with the different reducing agents, we have this is a different class of reducing agents. One is you see one is nickel, palladium, platinum along with the hydrogen gas.